Welcome to my first Blunami clinic, but not my first Blunami install. We today are working on a Weaver M1A in Pensy colors. Obviously, M1 is Pensy. So here's the tender. See the engine there. I will go ahead and just give you guys a brief description of what I've already done today to prep for this. I have gone through the engine, basically just cleaning it internally, lubricating everything, making sure the wires are good, that there's no shorts or any other issues of that matter, because we don't want to harm the Blunami board once it does get installed. That's pretty much it for the engine. This one just needed a thorough cleaning. It was pretty dusty. The grease was pretty hard, and that's about it. In the tender, I have basically just taken the shell off. Engine only had conventional control in it. So it had a small electronic E unit, and that's it. No speaker, no nothing. However, it did already have holes in the tender for a speaker. I'm guessing this model came with some sort of QSI or horn and whistle at some point, could have. So all I did was add a speaker. There is a parts list in chat for in the meeting description of the stage with all of the parts that you see me using and some of the tools. So trying to keep this as simple for everyone as possible. I know there was some questions regarding soldering, so we can go over a little bit of that. I did prep a lot of stuff so that this install goes relatively smoothly and without hitch. I'm going to go ahead and turn on smaller camera here. So this is my main buck converter. So what this is going to be doing is it will take DC current in and it will put a lower DC current out voltage. What this is allowing me to do is whatever variable voltage is coming into the engine, I can then bring it down to the expected voltage that I need. Now, this board is a little on the larger side because it does have current protection built into it, along with shorts protection. And also it is rated for 5 amps, which conveniently is what the 4408 Blunami board is rated for. I do have some custom-made 3D printed brackets, which the link to these are also in that document that we just spoke about. So in order to get started, what I'm going to do is set the voltage on my buck converter. Because right now, from the factory, the voltage is set for the maximum. So I have my voltmeter, I have it plugged into the output side of my buck converter, and then I'm just going to use a bench power supply set to 18 volts, which is what we're trying to achieve. Actually, I'm going to set it for 24 volts, which is going to be a little bit more of what this board's going to be getting from the bridge rectifier, which we will go over here shortly. So you see that it has a power light, it's lit up, and you can see that we're pushing 23.3 volts out of this thing, even though I'm giving it 24. So on this particular board, there's 2 small adjustment knobs, also known as potentiometers. The cut sheet for this one tells you which one's which, but since I've done a crap ton of these, the one on the left is for voltage, the one on the right is for current. So I'm going to adjust the voltage, keeping an eye on my multimeter over here. You can see as I'm turning this, the voltage is coming down. And the target that I'm looking for is 18. And the reason that I'm doing this and not just sending it whatever voltage I'm going to get out of the bridge rectifier is because I want to know exactly what I'm feeding my LEDs. I don't want to go higher or lower because then the light variables will all be a little different. I've also personally had 2 Blunami boards blow on me traveling to friends' layouts because they use Z4000s, which will go above 18 volts. So 18 volts AC rectified to DC actually becomes closer to 24 volts, which the Blunami board can handle. However, if you start pushing that to 20, 22 volts AC rectified, it's pushing the limitations of what the Blunami board can handle. So this is really the protector, right? Blunami board is over $200. This board is like $10. So I'd rather this fry than that fry. So that's why every install I do, I use these. Now for the current limiter, I'm going to crank this the whole way up until I can hear it click inside, which means that it's at the maximum range. This board's capable of 5 amps. Blunami board can do 5 amps. So setting that to its maximum. Now that that is set, I can go ahead and remove power. Set that off to the side. I'm going to go ahead and remove my multimeter. We should be done with that for now. The other nice thing about the Weaver models is it is a 4-wire tether. Just a little kind of hard to focus. Apologize. Camera's not the most expensive, but it's just a little 4-wire tether. And the nice thing about the Weaver models is the headlight and the smokestack and the markers, they all are independent. They have their own control already in the engine. There's a switch under the cab to turn the smoke unit on and off. So what these 4 wires are doing is we're getting track power back from the engine to the tender, and then motor control from the tender back to the engine. So super simple case study for this one. What I'm going to do now is grab my handy dandy soldering iron. Link also in the in that spreadsheet, along with some solder. And I know some guys were asking about how do you solder? Soldering 101, right? On the smaller camera, you may be able to see that I have a wet sponge over here. I'm using that to clean the soldering tip. I currently have the temperature of this set to 740 degrees. I like to run them hot because that way you're not working on the project for as long. So the heat should be going into the solder, not into the components. So all I'm going to do is tin these wires, put a little bit of solder on the soldering iron. You see how it kind of flowed? It flowed onto the soldering iron. It didn't ball up. That means the soldering tip is nice and clean. If you guys are having problems soldering and with the solder just balling up on the end of your soldering tip, it means your tip needs to be cleaned, in which case you want to get some tip tinner. That's also just Amazon or has it or any of your electronic stores. So once there's a little bit of solder on the end of the soldering iron, you want to put it on your workpiece. In this case, it's a piece of wire, and you're going to start adding some more of that solder, and it should flow right into whatever you're working on. If it's beating up and rolling off, you're either not hot enough or you're using the wrong kind of solder. You can't just be using your grandpappy's solder that he used to solder copper pipes. That is not the same stuff. This is rosin core solder. It's basically got flux built into the solder itself so that it's cleaning and soldering at the same time. Yes, it is a little bit more expensive, but it's what's needed for something like this. So then moving on, we're going to set the bridge rectifier, or not yeah, that's not the bridge rectifier. This is. So we'll start with power. Power comes from the track. The only power pickups on this piece are in the engine. So that comes through the tether, and we're going to feed it directly into this bridge rectifier. Now, the bridge rectifier is the solid piece with the four connectors on the bottom. Across that is a capacitor to filter out the flickering that happens with AC power. So this is just going to give us a more of a steady stream of DC power. The stripe side of the capacitor is negative, so you're going to want to solder that to your negative terminal on the bridge rectifier, and then opposite side to the positive. And then on this particular model of bridge rectifier, the center two conductors are your AC power in. As far as electronics are concerned, or electricity, I should say, AC power, it's alternating back and forth. It's alternating current. That's what AC stands for. So positive and negative does not matter in this case when you are talking about power. Now, when you're talking about MTH or legacy, yes, but that's because they're sending digital signals over the rails. So in this wire harness, this 4-pin or 4-conductor wire harness, I know that my outside two wires are my motor connections, so I'm going to set those aside. And then my inner two connectors, wires, are my AC power. So since I've already tinned those, or put solder on the ends of them, also known as tinning, and I already tinned the end of my bridge rectifier, all I have to do is line my wire up, apply some heat, and this is a little easier said than done when you're trying to talk. Apply some heat, and it just flows. You can see that there's no wire sticking out. There's no visible wire. It all looks like one smooth, solid lump. That's what you're looking for. So I'm going to go ahead and do the other one. Now, some of you with a keen eye might say, hey, why didn't you put any shrink tube on the end of that? Well, because it'd be a waste of time and money, quite frankly. Because you'll notice this white thing on the back. This is called dual lock. There's a link for that as well in the spreadsheet. This dual lock is great because it's essentially Velcro, right? But it's not hook and loop because both sides are the same. They interlock together, and it's sticky. So basically peel and stick. And it's 3M, so it ain't going anywhere. So I'm going to just, I kind of planned out where I wanted to put everything before I got started. So I'm going to shove that on here, press it down, hold it for a few seconds. And now, if any of these components ever need to be replaced, all you got to do is pop them right off. Pops right back on. And it's strong enough that I can literally lift the entire tender. So you got to really hold it down to pull it off. You'll notice the glue's not giving way. So I didn't feel like there was any need to have to shrink these because nothing's ever going to come even close to touching it. There are other cases where shrink tube is necessary. For example, we've got two different connectors that I've preemptively soldered up here. I'll explain what all this is here in a second. But because these are going to be moving around and possibly touching other things inside of the tender, I did use clear shrink tube on these. I just happen to have clear in the right size, or any color would work realistically. I do prefer to use clear on my wire connections, just because you don't have to take the shrink tube off to see if the wire is still, properly soldered. So, I mean, I can visually inspect that and see it's still good. So On our DC out of the bridge rectifier, I have 2 wires each. I've got 2 hots and 2 grounds. One of the hots and one of the grounds is going to be going into my 5-volt buck converter, this guy right here. The other one, the other set, is actually going into a much smaller buck converter. And it's probably a little hard to tell, but there is a very small adjustment screw, again, potentiometer, built into the board. I set this to 2 volts. And what this is going to do is it's going to run my marker lights in the tender, and it's also going to power my rear backup light, but only the hot. You'll notice that the ground, I did not attach to anything. That ground is going to go to the Blunami board under your backup light, BL, on the board. Not sure how well this is going to show up on camera. All of the ports on the Blunami boards are labeled as to what they do, what they are. There is a wiring schematic that comes in the packaging of each one of these. We'll just go down one side real quick. So you have HL for headlight, BL for backup light, F3, F4, 5, 6, S minus and S plus. The S minus and S plus is your speaker connection. F3, 4, 5, and 6 are your FX ports, which are completely programmable inside of the app. So those would be for all of your different lighting features or your smoke control, or in an example of possibly doing a GG1, that would be your pantograph control, if they have automated pantographs in them. Basically, if you can control it with a relay, you can control it with a Blunami board. So very universal. The other side is LR for left rail, M minus for motor ground, F7 ground, V plus, F8 M plus motor positive, and RR for right rail. So Blunami is designed to be used in a 2-rail system. It was, I don't want to say it wasn't designed for 3-rail, but it really wasn't, which is why we have to have all this extra stuff to adapt AC power to DC power. But the fact that this is labeled left rail and right rail and not positive and negative means that we can feed this power in any direction. It's not going to hurt the board at all. So we had set the voltage on this guy. We're going to go ahead and find my 3D printed bracket here. This just fits nicely. It's just a press fit. I say that, now I can't get it to fit. There it goes. So that's just a nice press fit in there. Here's another example of the dual lock. This is both pieces put together, cut to length, rip off the label, put it on the back of my mount that I made. If you guys don't have 3D printers or don't know anybody that has one that could let you borrow it, or give you some print time, you could literally just use dual lock right on the back of the boards if you really want to. I don't recommend it, because if you ever have to pull that off, there's a chance you could rip some of these components off the board with it by accident. But in a pinch, it will do. So the reason why I am getting all of this lined up currently is because I want to get this in place as to where I want to put it. When placing things on your tender, I always like to make sure that there is enough height in here, which there totally is this time. But some tenders have lower areas and higher areas internally. This one does, but it's not that much of a difference. But you'll also notice like up here, there's a bump down. So like I don't want to put the Blunami board right at the edge, you know, because then it's gonna get in the way. So what I like to do is I try to get it pretty centered in a nice spot where everything's out of the way. So now that that's seated down, go ahead and take my hot wire from the bridge rectifier. I'm going to feed it through here. And I'm going to leave myself a little bit of a service loop. I don't like to make the wires too tight. That's just personal preference. Go ahead and cut that. Strip it. I do keep looking up, so if anyone's got questions, please feel free to request to speak. So that's my hot wire connected. Now this thing's starting to bug me, so I'm going to go ahead and stick this down as well. This is the smaller buck converter that is just running the rear lights. So now that that's done floating away. One other thing to kind of mention here too is you'll see in the tender here, there's a ridge because this is a brass tender. There's two ridges, one on either side where the screws go in. So you got to make sure that that room is free on the side of the boards or of the tender shell or chassis. Wow, easy for me to say. I've only been working on this thing since about 10 a.m., so forgive me. So, right, still got to do ground. Cut that. Strip that. Just do a nice little twist on the wire since it is stranded. Gives a better bite when you put the screw in. And for those of you that are seeing my fat sausage fingers and wondering how the hell is he doing all of that, if I knew, I would tell you. It's just one of those things. Also, always do a tug test. I just thought I had this wire in there, and I gave it a tug after what I thought the screw was down, and it came right out. So try this again. All right, that is now in. So then what I'm going to do is we still got to get power back out of this buck converter. Okay, so now that all four of my screw connections are done on here, I'm going to just gently pop this back up so that I can remove one side. That way I can slide the Blunami board into my holder. It is just a press fit, but the nice thing about this press fit is once everything's together, the 3M dual lock keeps the sides from coming apart. So kind of all locks itself together now. It ain't going anywhere. So then what I'm going to do is we've got our power coming out from underneath. Let's see if I can zoom in just a little bit more here for you guys. So our power is coming out from underneath in the buck converter. And what I'm going to do is we're just going to loop this around. So I'm going to put this, kind of hard to read, but this is the right rail connection. Like I said, the polarity here really doesn't matter. However, in my mind, because it says RR for right rail, I'm thinking R for red. So It's just, I just know that works, and my brain's weird that way sometimes. Stick it in a hole, screw it down. And we're going to do the same thing for the ground. Again, leaving myself a little bit of service room so that if I ever have to restrip or cut or something, there's enough wire here to do it. All right. So that, let's go back to the tether, right? Because we're got to worry about those 4 wires from the engine. So we've got 2 wires left. Like I said, those are the motor connections. Polarity for the motor does matter. However, there is a setting inside of the Blunami app where you can change the motor polarity. A word of caution, if doing that, you're going to have to go in and manually change your front and rear light controls so that they match. I highly recommend just testing everything before you put the shell back on, because it's so much easier just to flip the wires around. I know from experience that the fireman side of the engine is negative, motor negative. But again, that's just from experience. So I'm going to go ahead and put that where it needs to go. And then the last wire from the tether. Get my motor hot. We are almost done with this part, gents. So going back to the lights that are in the tender, this is going to be just straight power to the marker lights. So I'm not controlling the marker lights. I do like to have a light or 2 on the engine that just come on with track power so that you know the engine has power. That's, again, personal preference. The other one is for the backup light, which we only want to turn on when in reverse. So that control, which the FX ports on the Blunami board, they control ground, not hot. So that's why you see the ground wire here going for the backup light. I'm going to bring that around and screw that down to the backup light connection spot. By controlling grounds and not controlling the hots, you're allowing different voltages to be able to enter different devices and then ground using the Blunami board. Within limitations, obviously. Can't run smoke units directly off of a Blunami board, but you can run a relay off of the Blunami board, and that relay can then control smoke units. With this Weaver, though, it's got a Sooth smoke unit in it, and quite honestly, they work perfectly fine. They work great. They actually are a lot less noisy than some modern fan-driven units. So I'm going to just leave that as is. All I'm doing here is shoving some of this excess wire for the motor connections kind of just into my sandwiched boards here to kind of hold it in place. could have cut those a little shorter and given myself a little less of a hassle, but something else I like to do as well is kind of helps with the user experience. I figure out which way my plug needs to go, whether this side up or that side up. I know in this case it's this side up. It's not the same for everything. But what I'm going to do is I'm going to pull my wires out at the same length. That's all she wrote with the length, and then I'm going to put this zip tie on this, so that way when the user or yourself goes to plug in the engine or unplug the engine, that the wires are going to all kind of maintain the same length. So it's going to be one cohesive harness and not 4 wires wanting to go in all the different directions. I've also done it where you use a very thin wire sock, especially with the larger tethers with multiple pins. All right, so that is ready to go. If I were to toss this on the track and plug it into the engine right now, we would have everything that's expected other than sound, because still got to wire up the speaker. On the speaker, it says that this side's negative, so negative's blue. Just untwist my wires here. Go ahead, cut them. Okay. That's all of my connections that I need to the Blunami board. The other 2 things are just the plugs to the lights in the tender. Now realizing you guys can't see that. Zoom out a little. This has gone way smoother than I anticipated, but again, I did a lot of prep work. Didn't want to waste everyone's time. Obviously, soldering things takes time. Shrink tubing things takes time. Figuring out voltages and where wire goes takes time. Laying everything out takes time. This engine does not have an electrocoupler. It's just a regular sprung coupler, obviously because it had just conventional control. There is a separate little electrocoupler control board that I can put into these if you want to do it yourself. They're not commercially available. Gunrunner John from the OGR forum designed these, and I had a bunch of them made for my installs. If anyone's interested in those, just let me know. I'm sure I could solder one up together for you and ship it out. Basically, what that board does is it's got 2 wires for the front coupler, 2 wires for the rear coupler, power into it. So you would set the power voltage to whatever voltage the couplers are expecting. Lionel couplers like to fire between 12, 13, 14 volts. And MTH couplers like to fire at 5 volts. So it's a big difference in voltage there. That's also why, if anyone's noticed, MTH couplers are a lot quieter when fired. Lionels love to buzz. That buzz because of the higher voltage. And then Blunami will control that board via 2 of the FX ports, one for front and one for rear. And all that's doing is it's controlling that little board, switching the power on and off. I'm not going to pop the tender on just yet, but let me go ahead and change camera angles here and get this guy moved around. Now, keep in mind, I'm doing this live, so don't take it easy on me, because if something fries, there's a chance that it might have been a defect from factory. So, gonna go ahead and give it power. I don't know if you guys are going to pick up the audio for this. Let me see if I can turn off my noise suppression. So here you can see it came right up, Blunami V1.0. This board, yeah, that's not gonna fly. Great. This board is brand new. I did not program anything ahead of time. Let's see if I can switch to this guy. Yeah, kind of hard to read some of the stuff, but so here it's going to load the CV values at the top. This part does take a little longer than one would hope, but there it is. It's done. It's loaded. First thing I like to do is go in to general settings and rename it. In this case, we're going to go with PRRM1A. Okay. And in the sort list, I'm just going to call it the same thing. This is completely customizable on the fly. Anyone can do it. It's not like I'm setting something in stone here. And then for the DCC address, this really only matters when you're doing actual DCC control, which since we're all using this via Bluetooth, it doesn't really matter. But I like to set it to the engine cab number just so that it's different. You'll see that that took 6755. Couple other simple settings that you can check out here. Really nothing crazy. I know some guys like to have throttle feedback, which means you have a bigger plus and minus button on the screen, and when you tap them, the phone vibrates. So I have not played with that myself. The sounds are a little loud for me, so I'm going to go ahead and turn them down. I do know from experience that with these speakers, 90 is perfectly loud. So just going back into here. One of the other nice things is if you want it to act more like the Bluetooth from Lionel, whereas if the phone becomes disconnected from my train, stop the train, there's a setting for that. On disconnect, you can stop or continue. I like the option of continuing because especially if you're running for the holidays, you want to be able to walk away with your phone and have the trains keep running. Out of the box, the Blunami board is capable of sending your train the maximum amount of voltage. So especially with engines like this where it's a very large motor, it has a potential of very high rates of speed. So I always like to come in here and really cut down on the amount of speed that's even possible. So my midpoint 40, and again, this is all can be done by anybody. But you'll see that my max speed is 80. You can't see the numbers, but believe me, it's 80 out of 255. So that's how much I'm cutting back the speed, and you'll see that that's going to be perfectly adequate speed. You can also change the acceleration and deceleration rates, which you can with Lionel and MTH as well. However, MTH's slowest acceleration and slowest deceleration is still very quick for me personally. Lionel does a bit better of a job, and then this is like that on steroids. So an acceleration rate, which may actually be too long for some, I'm only going to take it to 30 out of 255. And then I make my braking rate a lot less, usually half, because And if you think about the grand scheme of things, you're going to have a whole train worth of brakes versus one engine to pull. So acceleration would be a lot slower than deceleration. Gonna change the speed table. So there's 3 different choices here. I know it's hard to see. I do apologize. I don't know why the camera's not quite working on that. It's like completely washed out. Kind of there now. So the default 3-point is obviously default. It's how it comes loaded. The 3-point table I just set, so I'm going to select that one. And then there's actually a 28-point user-defined table that you can build as well. So you can really affect how much throttle, like how fast each throttle response is. I've never had to go that far with it. We're not HO guys. So I'm going to hit OK. That's pretty much all I do for that. Light settings, there's no extra features in this one, but this is where you would set up the extra FX ports. So say, for example, I had this light and I wanted it to do, I don't know, be a Mars light. You know, I could select that and the Blunami board would make it act that way. Just going to go ahead and change some stuff here. I did keep the original marker lights, which are already LEDs, and I kept the original backup light, which is like a grain of wheat bulb. I did test them before assuming that they worked, so 2 volts was enough. Another setting that a lot of guys do appreciate is this engine, the sound fired up immediately when I gave it power. One of the things that you can do is if you go into other settings under sounds, you can change quiet mode timeout. So by changing this, I just said 30 seconds with, if you don't have any of the FX turned on, after 30 seconds, the engine will completely go to sleep in terms of sound. Now say you want to wake it up. All you got to do is turn the lights on. The dynamo kicks in. It's doing its thing. We've got bell, whistle. Not really sure you guys are hearing any of that. I'm not seeing my mic light up when I hit it. But trust me, it's loud. And that's with the tender off. It will get a lot louder once the tender gets put on. You'll notice that the name did not change at the top of the app, even though I had set it in here. That's an app issue. That's not a Blunami issue. So I'm going to actually go ahead and close the app completely and reopen it. Now when it scans, it's not wanting to show up again. Trust me, it's there. It says PRRM1A now. Yeah, right there at the top of the screen. It's going to load the CV values again. Just takes a few seconds. At the end of the world. There's a absolute crap ton of other settings to go through here. Soundtracks has a really good set of videos to go through, and they will walk you through pretty much every setting. This was more about how to install it. But if you want to get sold on it at all, this is the list of whistles. There are 90 plus whistles just for steam engines in here. Do they have every whistle known to man? The answer is no. There's just no way, because some railroads made their own whistles. But is there European stuff? Sure. Is there N&W stuff? Yeah. Is there PRR stuff? There sure is. Reading. Keep in mind, Soundtracks, the company is based out of Colorado. So there is a lot of Colorado Railroad stuff in here. But there's a Heisler whistle. There's even some air horns for some of the daylight engines, the GSs. Some more British stuff. Basically, what I try to do for my customers is if I can't find online what type of whistle a certain engine was very quickly, I just find one that at least fits the same road name. But there's also a crap ton of different bells, from heavy brass, light brass, medium brass. There's, I think, 2 or 3 different types of heavy brass, and each one has 5 different ring speeds to choose from. So really customizable. All kinds of different air pumps. I know personally, I think cross compound number 4 sounds best to me, but that's just me. Heavy coupler, medium coupler sounds. Really not sure why microphone's not picking all that up, but there's different dynamos to choose from. And again, this can all be set by you. This is not just the installer said it this way, this is how it has to be. No. If you want it to sound one way one day and sound a different way, an hour later, you can change everything on the fly. It's a beautiful, beautiful thing about this. One thing I do like to turn on is automatic brake squeal, so that when you throttle back really fast, it will apply the air brake sounds. The other thing I like to do as well is cylinder cocks enabled, so that when you take off, even after direction change, the cylinder cocks will automatically play for a little bit. So that's probably enough of me talking. Probably want to see if my install made it run, right? So keep in mind, this was a conventional engine before. We're sitting on the track at full voltage. You can actually see right here, the Blunami board is reading 18 volts on the dot. So if I hit the plus button, oh, look, a conventional engine that's crawling. Absolutely crawling. So everybody, I think the only thing that's really left is to put the tender shell on, plug in the lights, and test those. Let me switch cameras here. Move this around. Turn off track power. Another thing I like to do too, personally, is after it's been on and running, kind of feel the components, see if anything's hot. Hot usually means something's wrong, and everything is ice cold. So that's a bonus. There we go. Let's see everything I'm doing here. Could probably use a Sharpie and color code these if you really wanted to, but which, now that I say that, is probably a good idea. one of the most important steps here is when you're putting everything together, make sure you're not pinching any wires. Nothing kills a Blunami install like pinched wires, or any install for that matter. Pinch a wire, you might as well just go home. All right. Everything is in there, seated nice. The tether's sliding in and out nicely. Nothing's pinched. If I was smart, I'd probably should try the lights before putting the shell back on, but I fully have faith that if this was meant to be, it'll be. Does anybody have any questions while I'm turning some screws? Please feel free to request to speak, and I can invite you to stage, or Joker can if he's still around. It's been very quiet.
I'm still here.
Good.
Guys got questions? Speak up, boys.
I'm here for you guys. You know, it's questions are good. I need some feedback. Am I going too fast? Am I going too slow? Is this boring? Did I miss something? I really feel like I may have gone a little fast for this, but I figured I didn't want to waste everyone's time by sitting here soldering stuff. Like, yeah, I can get it, dude. I solder a lot of crap. Welcome.
Hi. So I know I think I might have missed this part, but it's a three-rail engine. So, and you said it's primarily designed for two-rail use.
Correct.
So did you just wire the third rail pickup into one of the pickups that was meant for the second rail?
So that's what the bridge rectifier is for. So the power comes off of the track through normal means into the bridge rectifier. We're going to convert AC to DC. And then we are using the buck converter to bring down the voltage to a steady 18 volts DC, and then we're feeding that into the Blunami board.
Okay, so on three-rail engines, you need a rectifier.
Correct. Yes.
Oh.
And I know some guys that have 2-rail models still want to be able to run them on 3-rail layouts. So in that case, I would still install a bridge rectifier, because that way it will work. You can feed DC into a bridge rectifier and you'll still get DC out. That's not going to hurt anything, but when you feed it AC, it will convert it to DC. So it doesn't hurt to put that in there. The only reason, or the only way I would ever recommend taking straight track power to a Blunami board is if you are trying to run DCC like through a handheld, through an actual like MRC or Digitrack system.
Okay.
In which case, if you're running that, you know the other Tsunami products, right? So you'd be kind of wasting money on a Blunami board. So now that the shell's back on, let's power back up here, see if I'm going to blow up the marker lights. Oh, they didn't blow up. Yay. I've been having a hell of a time with marker lights lately. So the fact that they didn't blow up is good. Let me pull forward a little. Now that we've pulled forward, put it in reverse. And look at that, no reverse light. Cool. So that'll have to be something that I troubleshoot. But It's weird. I did test that. Well, other than figuring out why that reverse light's not coming on, which I don't think it's a wiring issue. I think the bulb might have blown because they tend to do that on me. Does anybody else have any questions? Because if not, I think we can wrap it up. Give everybody back some of their time. Ah, that would do it. The wire is so thin, it just snapped. So before I break anything, power it down. That is one bad side of reusing existing lights. Sometimes they don't work. So for those of you that were curious as to what the issue is with the backup light, the connector, the wire had snapped off inside of the connector. So had to try recrimping it, and it just broke the wire again. So this time I soldered it instead. So we should be good to go now. And the last thing that I want to do before packing this up to send to the client is test the smoke unit. Even though it's just a sleuth, still want to test it, make sure it works. Because the headlight worked, the front marker lights worked. Rear marker light is now working. And the reason the smoke unit's not going that hard is because I literally just put a drop or two in. I just wanted to test it. As one thing about the sleuth units, or sorry, sooth units, there's no L in there. The sooth units, if you turn the engine upside down, the smoke fluid literally just falls right out. So I didn't want to put too much in there, but smoking pretty good. It's amazing what a Blunami board can do for these older models. You know, something that somebody like me, who's all command, wouldn't think twice of buying just because it's conventional. But I think some of these engines I've seen go for pretty cheap, and it's a gorgeous piece. But if anyone has any last questions, now is your chance. Joker, did you hear any of that?
Very, very faint.
I don't know how to get audio to work better. Even though noise suppression's turned off. Oh, let me try this.
It's a little better, yeah. Went back away. Yeah, I can hear that.
All right. That's the short whistle burst. It seems like the long one gets canceled out.
Ah, Johnny is here from Optimus.
Hi, pal.
Would you like to talk, Johnny?
Too late, I already invited him.
Hello, hello.
Hi, Johnny. Welcome to the end of the video.
Sorry, better be late than never, I suppose.
Yeah. Everything went pretty smoothly. Had a rear light issue, but got it fixed.
Nice.
Wire broke off inside of the connector. That's always fun.
Oh, wouldn't be a proper install without one.